Okay, in this vodcast, what we're going to do is take a look at what we call percent yield. And basically, percent yield is nothing more than a measure of how well you did a lab. So, for example, let's say you're reacting hydrogen and oxygen and you're producing water. And you calculate that you're supposed to produce 10 grams of water. So you do the lab and you actually produce 9 grams. After you weigh out the water, you find that you have 9 grams. You were supposed to make 10, you were able to make 9, so your percent yield, as you probably have already guessed, is going to be 90%. So percent yield is nothing more than a quantitative measurement of how well you did that lab. And it really is a very simple equation. You've got your actual yield over the theoretical yield times 100%. Now, I just want to point something out here. You learn in your math class that when you have a percentage, you put it in decimal form. But what you're doing here is you're producing a percentage. So you have to multiply your value times 100 and then tack on the percentage symbol. Alright, the toughest part about these problems usually is figuring out what's your actual and what's your theoretical. And it really is pretty simple. The actual yield is either the laboratory value, so in other words, if you're doing the lab, that's the value that you measure, that you found in the lab. If it's an exam situation, then that would be the hypothetical lab value. In fact, oftentimes it's referred to as the lab yield, not the actual. Your theoretical then is your known value. So for example, if you are measuring the boiling point of water, your theoretical value would be 100 degrees. In fact, oftentimes it's just referred to as your actual value and theoretical value. So this slide just reiterates what we said. Your actual value or actual yield is the hypothetical lab value or the real value from your lab exercise. Your theoretical is then the known value, for example, the boiling point of water, 100 degrees. If it's not a known value, then it's the value that you calculate doing the stoichiometry. And this is important. If you're trying to find what that theoretical value is and you get confused, the theoretical value is always going to be the value that you calculate. And then the actual value is the lab value or the hypothetical lab value. So remember that when you do the stoichiometry, your calculated value is your theoretical value. Okay, let's do a couple of example problems. So your problem here is you've got 8 grams of butane, you're reacting it with oxygen to produce carbon dioxide, and you want to know what's the percent yield. So you know that the percent yield is the actual over the theoretical times 100. Okay, the first step in this process then is to write a balanced equation. So let's write butane C4H10 is reacting with oxygen. Now right away you should recognize this as a combustion reaction. You've got your hydrocarbon, it's reacting with oxygen, so you know the two products are going to be carbon dioxide and water. So let's balance it. We've got 4 carbons, so we'll put a 4 there. You've got 10 hydrogens, so we're going to put a 5 there to give us 10. Now our oxygens, we've got 8 and 5, which is 13. Now we can't put a whole number coefficient here to make that 13. Nothing times 2 is 13, whole number wise. So what we're going to do in this case, like we talked about before, we're going to double these values. We're going to put an 8 there and a 10 there. Go back and rebalance your carbons, and now you'll see your hydrogens balance. Now we've got 16 and 10, which is 26 oxygens, so we can put a 13 there. Okay, so we've got 8 grams of butane, and it's going to make 15 grams of carbon dioxide. So the question becomes, if we're trying to figure out the percent yield of this product, is that the actual value or the theoretical value? Now remember, the theoretical is the value that we calculate doing stoichiometry. So when we take our 8 grams of the C4H10 and calculate how many grams of that it should make, that would be the theoretical value. So let's do that. We've got 8 grams C4H10. We need to convert to moles. So 4 times 12 plus 10 times 1 is 58 grams C4H10 per mole C4H10. So our grams cancel. Now we've got moles of C4H10, so we want to get rid of that. So we're going to put moles C4H10 on the bottom. We're calculating our carbon dioxide, so we'll put that in the numerator. Mole ratio, we have 2 C4H10s and 8 carbon dioxides. So our moles cancel. Now we have moles of carbon dioxide. Let's go to grams. 1 mole carbon dioxide is 44 grams. 12 plus 2 times 16. So our moles cancel. When we do the math there, we get 24.3 grams of the carbon dioxide. Now remember, that's the value that we calculated, so that's going to go in our denominator. The value that we're given as the hypothetical lab value goes in our numerator, times 100% is equal to 61.7% yield. Now that might seem pretty low in terms of grades. You would say, well, that's a D, but not necessarily. In a chemical reaction of this type, a 61% yield might be a very good yield. It all depends on the situation. Okay, let's take a look at another type of problem. Now it says what's the mass of P4, so we're looking for grams, is needed to produce 85 grams of the PF3 if the reaction has a 64.9% yield. So now in this situation, you're given the percent yield first, and you've got to figure out how to calculate our grams of P4. Okay, we have 85 grams of PF3. So first of all, let's write what we know. So if we had our actual over our theoretical times 100, we know that's going to equal 64.9. So the question becomes, do we know the actual or theoretical? If you look at the wording of the question, to produce 85 grams, that means that would be your hypothetical amount you produced in the lab. So we would know we have 85 over, let's just call our unknown x, times 100 is equal to 64.9. Now the question might be, well, what does that tell us and how did you know how to do that? First of all, let's address the first question. What we're trying to find is our value of P4. We know that if we had a value here, we could calculate how much of that we should theoretically have. So, if we know how much we theoretically have, we can work backwards and calculate how much we started with. So we're going to calculate the theoretical, solving for x, and then go backwards. To address the second part of the question, sometimes you might not be entirely sure how to do a problem. So what you do is you set up what you know, fill in everything, and then the unknown, figure out if you can use that unknown to find what you're looking for. And in this case, we were able to. So in this problem, if we solve for x, we are going to get 0.0076. No, we're not. We're going to get 130 actually, let's just put it at 131. So that's going to be our theoretical value of the PF3. So what we're going to do is take 131 grams PF3, and we're going to do the stoichiometry now to figure out grams of P4. So let's add up the molar mass of PF3. We've got phosphorus at 31 plus 3 times 19 gives us 88 grams of the PF3 per mole PF3. So our grams cancel. There's 4 moles PF3 for every 1 mole of P4, and then 1 mole P4 is 32 times 4 is 128 grams of the P4. Everything cancels except our grams of P4. So let's finish the math here. 131 divided by 88 divided by 4 times 128, and we get 47.6 grams of P4. Now you see the value here, 46.1. That's simply a difference in sig figs. I can go back and check the math, but you see that's close enough for our purposes. Okay, so anyway, again, you were given the percent yield and the actual, so we calculated the theoretical and then used that to calculate backwards what amount of P4 would have produced that theoretical value. Okay, so that's it for percent yield. Again, it's basically a quantitative measure of how well you did the lab. As usual, do some practice problems with these, and if you can do stoichiometry, you can certainly do theoretical yield.